we're going to talk about the definition of a parabola and where it comes from. Now, we are used to recognizing that a parabola is the graphical representation of a quadratic function. And remember, a quadratic function in expanded form is something like this. We also have seen it in what we call the standard form, and these are the same equation, but the standard form is listed this way, same y, where h and k is our vertex. But we're going to put that on hold for just a minute and talk about the graph of a parabola, the definition of a parabola, the shape itself. What does that mean? And what we're going to consider it is if we have a point called a focus, and you can see in the visual I've got the Cartesian grid. We've got a parabola centered at the origin, and then there's a little P on the y-axis, and that point P is called the focus. And then there is, you can see the green lines give the axis, but then the dotted line underneath is the line y equals negative p, and that's called the directrix. And if you see the xy point over here, okay, so that's considered to be any point on a parabola. And if you notice that point, if you draw a line to the focus, this D1 line, and then you draw a line down, a perpendicular line to the directrix, those lines are the same, so that D1 is equal to D2. So in other words, a parabola is defined to be all points that are the same distance from the focus and the directrix. Okay, so think about the focus. That is at the point 0p, and then the point where it's perpendicular to the directrix. Notice it would have the same x value as our point in question, and then the y value would be negative p. So what I want to claim is if D1 is equal to D2, then the distance between 0p and xy is the same as the distance between xy and x negative p. And so we're going to use our distance formula. Remember, the distance formula is given by the square root of x2 minus x1 squared plus y2 minus y1 squared for our 2 points x1, x2, x1, y1. That's supposed to be a 1 there. x1, y1, and x2, y2. So if we look at the distance between D1 as the distance between x, y, and 0p, then we can write that as the square root of x minus 0 squared plus y minus p squared. And then D2 can be written as the distance between xy and x negative p. So that's going to be the square root of x minus x squared plus y minus negative p squared. Okay, so in this first radical, we get x squared plus y minus p squared. Well, if I expand that out, that's going to be y squared minus 2py plus p squared. And then over here, x minus x squared, that would be 0 squared. And then if I expand that, that's y plus 2 squared. So y squared plus 2py plus p squared. All right, now I'm going to take the square root of both sides, and we've got x squared plus y squared minus 2py plus p squared is equal to y squared plus 2py plus p squared. So our y squares are going to cancel on either side. They balance each other out. Our p squares are going to cancel on either side. And what we end up with is x squared equals 4py. All right, so x squared equals 4py. Now, this is the equation of a open upward parabola, just like in our diagram, the equation of an open upward parabola, so x squared equals 4py is the relationship in question. Now, notice if we thought about, okay, so this x squared equals 4py is the geometric definition of a parabola. How we thought of it in the past, let's say this particular parabola, if it's sitting on the origin, that y equals x squared is a parabola sitting on the origin, and let's just say that our coefficient is a, so it might be like 5x squared or something like that. We know what that looks like. Well, it's the same relationship that we have here. Okay, so the a that we're used to working with in a this a that we're used to seeing as our leading coefficient in a quadratic equation, from this algebraic definition that we're used to seeing versus this new geometric definition, we can see that if our 4p, like if we were to move the a to the other side, we would have 1 over a times y is equal to x squared. And so basically we'd have 1 over a is equal to 4p. Or sometimes you'll see it the other way around. A is equal to 1 over 4p. And again, our focus is the point x equals 0, y equals p, and the directrix would be y equals negative p. And one more thing, I'm just going to erase this so we'll have a little bit more room. So this is the open upwards parabola. And again, this is a little bit separate than talking about functions, but just put it in the little box over here. Let's choose red. If we have a parabola that is open sideways, or open to the right, then the definition for that, using the same logic that we just did, using the distance formula, is going to be y squared equals 4px. And your focus would be at the point P0, and your directrix, instead of being y equal, would be x equal to negative p. So your focus would be that point, and then your directrix would be there. On the previous slide, we looked at a parabola in general form sitting on the origin is equal to x squared times 4py. This is considering that our parabola is sitting on the origin. A lot of the parabolas that we look at are going to have a little bit more to them. They're going to have shifts to them. For example, if we take this guy, x minus 6 squared equals 8 times y plus 1, we can see from the picture, from the graph, that we've got the vertex has a horizontal shift of 6, and a vertical shift of -1. So the vertex is actually 6, -1, and the focus appears to be at x equals 6, y equals 1, but the difference there, you can see, that's going to be our p, the difference between the vertex and the focus. And so I'm going to claim that our p is equal to 2. And let's just consider this equation and how it relates to quadratic equations that we've looked at in the past. Okay, first of all, usually we have equations where our y is isolated. So let's go ahead and look at what happens when we isolate y. Okay, if I move my 8 over, I've got x minus 6 squared minus 8 equals 8y. And solving that for 8, or for y, I would have 1 over 8 times x minus 6 squared minus 1 is equal to y. So from our previous knowledge of quadratic relationships, we do know that our h is 6 and that our y is negative 1. So that verifies what we see regarding the vertex. And then also, thinking of this as a times x minus h squared plus k form, we see that our a is equal to 1 over 8. And remember, we learned earlier that a is equal to 1 over 4p. So if this is the case, then our p in this situation, or in this example, is equal to 2. Okay, so that's what we claimed earlier. But I just wanted you to see that everything matches up from our previous relationships of quadratic functions and then this new definition that we have for parabola. So if you were to see a problem like this and you were asked to find the vertex and the focus and the directrix, so what we want to do is we find the vertex to be 6, negative 1, and then find our p, and then we're actually going to add the value of the p to get the focus. So our focus, remember the y value of our vertex was negative 1, and then when we add 2 to that, we get positive 1. So our focus is going to be at x equals 6, y equals 1, and then the directrix is going to be just the opposite. We start with our vertex of negative 1, and now we're going to subtract that value of p, and we get y equals negative 3. All right, so we've got the vertex, we've got the focus, we've got the directrix. Other things you might be asked, the axis of symmetry. The axis of symmetry is just the line that divides the parabola in two, just like it sounds. And for a open upward parabola, the axis of symmetry is going to be vertical. And so in this case, it's x equals 6. A parabola that's open upward is going to have, for an equation, y squared equals 4p times x. And if we have a shift, like here we have y minus 1 squared equals 4p times x minus negative 3, then that means our vertex has shifted from 0, 0 to the point x equals negative 3 and y equals 1. So we see that our equation is right here, but it corresponds to 4p equals 12, which means that our p is equal to 3. Now remember, the p is not necessarily the focus, but it's the distance between the vertex and the focus. And so here you can see our vertex is here at negative 3, positive 1. And you're just going to add 3 to the negative 3 to get that the focus is at 0, and then the y value hasn't changed, so it's still going to be positive 1. And then the directrix, again, you're going to start with the vertex of negative 3, and then you're going to subtract 3 to get that it is x equals negative 6. Our axis of symmetry, in this case, it's the horizontal axis. So our axis of symmetry is going to be y equals 1. And I don't know if I've mentioned this before, but if p is negative, then you're going to have a parabola that's open to the left. P is positive, you're going to have a parabola open to the right. And then for the open upward parabola, if the p is negative, it's going to be open downward instead. Okay, we want to write an equation with a vertex of negative 5, 1 and a directrix of x equals negative 13. Just do a little sketch. If we've got a vertex of negative 5, 1, that's about right here, and then a directrix of negative 13, x equals negative 13, we know we've got a vertical line for our directrix. That distance between our directrix and our vertex is actually 8, right? So if we do, to get that, we think of the difference between negative 5 and negative 13 is going to be 8. So that same distance, if we go 8 this direction, that's going to give us our focus. It's just a common sense way to figure that out. A parabola that's opening to the right is going to have y squared equals 4p times x. And we know the shift off the origin is going to be y minus 1 squared equals 4p times x plus 5. And then if our p is equal to 8, and we get p is equal to 8 just because, remember, that's the distance between the vertex and the focus, then we've got the equation y minus 1 squared equals 32 times x plus 5.